Hi everyone, welcome to Science Tech Day. Today I'm going to take you through on how diodes work, what is a diode, and the application of these diodes. And now, today generally we are going to talk about the PN diodes, because we have many kinds of diodes. I first have to say that a diode is made out of two leads, then it has a black body, then it has also a white strip which is surrounding it. And now, inside the diode, it's made out of a silicon, in which these silicons, in most cases, they add in some material to make it active, or to make it work, or to make the electrons move freely. You need to first of all understand what conductors are, and what semiconductors are, and what an insulator is. Because now these diodes can also work as an insulator, and can also work as a semiconductor or a conductor. What do I mean? That a diode, when you connect it when it's reverse biased, a diode won't allow a power to go through. So there it can work as an insulator. So that's why I'm telling you that I have to first take you through how these materials work. So a conductor in most cases, it's made out of a copper. That's why in most cases our wires are made out of a copper. Then it also has a rubber. This rubber protects the electrons to flow through it. And now the copper wire allows free electrons to flow through these wires freely. Then we also have a semiconductor. Now when I go through these semiconductors very well, a semiconductor can work as an insulator, or can also work as a conductor. For it to work very well, you should also add in some external conductor with your battery. Will allow the flow of electrons to go through very well. But when we go in how these things are applied in our diodes, in most cases in our diodes they use semiconductors. And you know it very well that a semiconductor can either work as an insulator or a conductor. But for a semiconductor to work very well, we need to add in some materials. Which materials am I talking of? These semiconductors are, in most cases, they are made out of a silicon. These silicons, for it to work or to be reactivated or to be activated, you need to add in some materials. For example, in most cases, in N-type, we use a phosphorus. So you dope in a phosphorus, then on the other N-type, the P-type, we always use aluminum. So they dope in aluminum. And now this action of adding in material in this silicon, that's the N-type and P-type doping. That's what it means. When you add in a material on this silicon, that's what we call the N and P-type doping. So then after adding these two materials, that's the aluminum on the P-type. It becomes the P-type after adding the aluminum. Then this side, we shall have a phosphorus. But what you have to know, that this silicons comes when it only has four pair of electrons. So for you to add in some more electrons, you have to have this phosphorus. So when you add in phosphorus, we shall have more electrons which will be moving freely on our silicon. Then the other side when you add in aluminum has 3 electrons. So when you add in this aluminum, so the other side it will also work very well and will become a positive. But remember, before I go very far, positive side of our diode is a hole, and then this side of the negative part of our diode is having electrons. It's covered with electrons. Then the other side is having a hole. So when we bring this diode after adding all this material, but remember first that this diodes is made out of 2 leads. That's the anode, the cathode part, and then we also have the anode part. But you have to know very well that the cathode part is that part where there is white strip. Then the anode part, that's where there's a black strip. Then when we bring these two leads, then we bring in the other layers, which we had already doped in our material. We bring the positive type, then we place it in our side, which is having the anode. Then we also bring negative type, Then we place it in this side where there's a cathode. Then after that, this between these two, the anode type and the cathode type, we have a region which is separating this. That's a depletion region. So what do I mean with this depletion region? This is a region which separates these two, the anode and the cathode part. This depletion region, there's also another science inside here, that when you connect this, there will be a slightly an electrons which will flow from the negative, that's the cathode part, then it goes to the hole. It will cover up some holes in the other side of the positive, that's the cathode, or the p-type. Then the hole which is in the p-type from the other side of the hole, it will go to the negative, that's where the electrons are, the n-type. Then after going there, then when the hole comes and goes here, these two regions, because I've said that they interchange slightly, that the hole comes from this side of positive, then it goes slightly to the negative. Then also the negative goes slightly to the positive. Then it will form a depletion region between there. And now, between this region, a potential difference of 0.7. But now between this region, you have to understand that these electrons, when there's a flow of electricity and it's reverse biased, the depletion region will be wider, will be widely opened. That means this will not allow the flow of electricity or the flow of electrons to go through. That's why they are saying there is a force. And now the reason why these electrons goes this side and the negative goes slightly this side, then the positive goes slightly, the whole goes slightly to the negative part. It's because that this thing, now this force will be in the middle there, which will not again allow the flow of electrons from the negative then going to the positive. That's why they made this thing very well, that a hole goes this side, then this one goes this side. Unless you add in an extra power or an extra force, that's when you will see the electrons will move from the negative then to the positive part. But now in diode, you have to know that we have a conventional flow, and then we also have what we call an electron flow. What do I mean when I say that there's an electron flow and there's a convectional flow? A convectional flow, that's when a current flows from the negative. Let me say that when a current flows from the positive, that's the anode part, then goes to going to the cathode part. In which with diodes, diode can't allow a conventional flow. A diode only allows an electron flow. So how do electrons flow? Electrons always move from the negative part of a diode, then goes to the positive part of a diode. So what you have to understand from a diode very well, that a diode can't be reverse biased, but it can only be forward biased. For example, when you connect your battery and you connect the positive terminal of your battery, then when you connect your diode very well, when maybe say when you are using a bulb and you connect it and you want your bulb to light very well, when you reverse your connection of your diode, or when you connect it improper, your diode, your LED won't light, or your light won't light. But when you connect your diodes very well in a circuit, your bulb will light very well. So in most cases, the diodes, that's why I even talked about it before, that a diode can work as an insulator and can also work as it's like a semiconductor. It can work as an insulator or a conductor. In that, a diode can prevent the flow of electricity when you connect it improper. But when you connect it properly, it will allow the flow of electricity to go through. But in the body of the diodes, when you're having your diodes, you need to read it very well. And the capacitor of the diodes is the names and the capacitor of the diodes is always indicated in the body of it. It's written in that black side of it. So when you are trying to replace your diode in your circuit, you have to read through that, and you have to measure your diode before replacing it in your board. Maybe there is a problem. You have to first of all you test it very well, and you see the unit and the capacitor of the power it can contain. Then after that you can maybe replace your diode very well. Diode can't allow power to be reversed. It has to be forwarded. So that's how a diode works. But before we go off from this, listeners and viewers, I'm telling you that we still have more episodes coming in. We shall also talk about the transformers, whereby we have the chopper transformers and we have the reservoir transformers. Then also we shall also talk about the transmitters, where we have the C bands, and then we also have the KU band, the KA band. We shall also talk about the different types of the antennas, where we have the Yagi antennas. We have different types. We shall also talk about the resistors, how resistors work, but you have to know how these resistors work. Remember it very well that the resistance, in most cases, limits the flow of electricity. And secondly, we also have different types of these resistors. We have the variable resistors, we have the fixed resistors, then we also have the light-dependent resistors. So that we also have that. So we are going to tackle many. We still have more episodes. So keep tuned. But before I go off from this lesson, I want also to just hint some types of these diodes. In diodes, we have light emitting diodes. You have to know that. We also have the Scotch diodes. We have many, but that we are going to tackle that in our next episode. So keep tuned, and be with us. Science Tech will offer you each and everything. Thank you.